1, 2. Do re mi. Oh. Do re mi. Uh-oh. Is the microphone always on? Is the microphone always on? Test, test, test. Okay. What? Okay. Maybe I just screwed everything up then. Now you hear the pooping bear. Shit. I can't tell if the microphone is always on or if I need to set up the microphone as an output source. It's like it's always on. Okay. What about desktop audio? No. Now I've got the headphone microphone on the headphones because it's just a little easier in the noisy room right now, and I haven't had time to set up the USB microphone yet. Okay, so here we get going. I need to actually. Okay, so here we get going. Oh, there we go. Let's not look directly into the light. I'm Sean Macbeth, and I'm the lead VR engineer at Notion Theory, and I'm working on a project called. There we go. Primrose Primrose is a framework for being able to make virtual reality applications in your browser, and uses browser-based idioms to make it very quick and very easy to put together basic virtual reality applications. And then this is me. I'm Sean Macbeth. I'm just a dude on the internet talking into a camera. Okay, so today I'm working on getting mouse, keyboard, and gamepad support back into the framework after I ripped it out in order to support the HTC Vive hand controllers. Um, so hopefully this will go well today, and we'll see what happens. All right, so here's some code, and here's some more code, and there's even more code. These are the basic classes. I'm gonna here's an idea. Let's go to single column mode. Let's zoom in so that people can possibly see what I'm writing. That's probably a good level. Okay. So the browser environment class in Primrose is the basic beginning point for all VR applications. Show you an app. Let's go to the meeting room app. The meeting room app here creates a browser environment object, and this is really just configuring different properties such as the starting quality. We can make this lower if we expect our users to always be on a smartphone of some kind that doesn't run very fast, or we can set it to high, which is the highest setting, to be able to always start off in a really fast mode. Oh, we're not even looking at code right now. I gotta do a better job of running my broadcaster. Okay, here we go. Browser environment. This is the basis for all applications using Primrose. Up above here are just some other bits of code for managing username and password. It's really just for a login screen, being able to get some settings out of the URL. These are really just like test settings. I can easily set up a number of different tests as different windows because of these because of these URL parameters. But for the most part, you would not use any of that. You would use meeting ID, has meeting ID, meeting ID spec. You would use these. Let me move these out of the way so it's a little clearer. There we go. And just make this really clear. Actually, it doesn't. It just fills out the form with a username so that it's easy to click, log in. Browser will auto fill in the password, and then just make it nice and simple. So for the most part, so this entire block you would not use in your application. Here I'm looking for an identifier for a particular meeting, and then we use a regular expression to search the search string. The search string in a URL, if I come over to one, that's just my local server. This is the search string in a URL. Comes after the question mark. It includes the question mark, actually. The search string includes the question mark. So it's when you perform a GET request to a web server, you can include parameters in that GET request as part of the search string rather than the request body. This is why people tend to build APIs around GET requests, even when it's not necessarily a good idea, because it's extremely easy to add parameters to it. So in this case, if we did not match anything, then we generate a random ID. If we did match something, then we read it out of the URL, and then we make our app key out of that. So this little bit of a prefix is just for me to be able to differentiate easily. I could look in my database and I could see, oh, people are using the meeting app, and I could compare all the meeting IDs afterwards and make a determination on how many separate sort of apps are running. So then all of my forms have, oops, no, I don't want to do that. If I open up meeting index, here we go. And scroll past some junk. I have a number of different HTML elements with an ID on them. Just like this. So password, username, email, all really basic sort of stuff. And so what this function call does is it just creates an object that has all of those elements as fields based off of their ID. It pulls in every element off of the page that has an ID parameter, and it sticks it in the object. So then here are some of the names of those objects, and I just map over this array to then read them out, and I make this array so that I can easily do things in groups on top of them. I'm sure this would be easier to do with jQuery, especially if you know jQuery very well, but jQuery is also kind of large. I'm trying to keep the number of dependencies down in the project. I don't want my particular framework to depend on much of any other people's code, so that you could come in and bring your own. If you wanted to use jQuery here, you certainly could. If you wanted to use Lodash, that's perfectly fine too. They all work, because this is not really a concern for Primrose, how you manage your login form. So here again, here's the environment, and this environment is going to auto scale its quality, which means that if frame rate drops below a certain target, then it will try to downscale the resolution of the rendering so that it can maintain fast frame rate. It's much more important to have a high frame rate than high resolution in a virtual reality experience. You want to be able to hit the native refresh rate of your monitor, or people will not be able to stomach their moving their heads around. You want to be able to have what's called a very low motion to photon latency. When a person moves, they need to be able to see that movement very, very quickly. You want to reduce that amount of time as much as possible. And there are a number of tricks to do that. With the Oculus hardware, they have something called asynchronous time warp that takes it completely out of the developer's hands. It's actually kind of a neat trick. They don't give you direct control over the rendering. You render to an off-screen buffer, and then they splat that off-screen buffer up onto the display. It's a stereo image, and whenever you move your head around, they move that image around a little bit. You tell them what pose you had, what the orientation and the position of your head was when you rendered that image, and they use that to recalculate where to put the image in case you don't send a new image in time. And this works very, very well. So this is an amazing bit of a hack. It's kind of really simple, and it works very well because it doesn't rely on the developer having to keep up with the rendering timeline. However, on Google Cardboard, we don't have this feature. So Primrose needs to react nicely and in that case, that's where auto scale quality comes from. So auto scale quality is reduce quality if things get slow. Auto rescale quality is increase quality if things get fast again. So there are some times where perhaps there are a lot of objects on the screen, and maybe you're live programming and you've done something that took a lot of processing, but then you stop doing that. Then you might want the quality level to come back up again. In this particular demo, that is not the case. So I'm making the assumption that if the quality had scaled down, we're going to want it to stay there, because it can be disorienting for the quality to be going up and down over and over again. And then this is the initial quality setting. If you know that in particular that your users are always going to be using a particularly low grade set of hardware, or your demo is particularly heavy, then you can set this to medium or low to automatically just start at a lower level for a higher frame rate. Ground texture is, this should be renamed ground material, and it is the color of, it is either a texture or a color to be applied to the ground. I give you a ground plane to be able to walk around easily. Somebody's talking to me? No, nobody's talking to me. Okay. What about on Twitch? Nobody's talking. Okay, that's fine. I have to check in. They want me to check in frequently. Disable default lighting. Background color is just what color the scene gets cleared out to. It's a WebGL setting, and it's really simple. It's going to default to this value regardless, but I leave it here because sometimes it's useful to set it to whatever the average color is. So here you can see that the room is mostly gray. It would be good to set the background color to this mostly gray value. If we ever like clipped through the wall like this, then it would be a little less disorienting. Or if we ever had some sort of transparent elements in the scene that didn't render 100% correctly, then the background color can bleed through, and setting the background color to something more appropriate for the scene can kind of hide that a little bit. Disable default lighting is for a case here where we've made a model that has lighting baked into the textures. So you see, it looks like there are lights in this room because there are shadows and everything is, everything is lit up. But these are all just, if you imagined having, if you imagined this table without the cups, the shadows would still be there because the shadows are painted onto the table. The shadows of the cups are painted onto the table. Or this wall back here, the shadow of the beam, if we removed the beam, the shadow of the beam would still be there. It's because the texture color has the shadow painted into it. And so with disable default lighting, it turns off the default light that I add to the scene in normal cases, so that you don't have conflicting lighting in your scene. Scene model is a model file, a 3D model file of some kind that you want to use as your level. Avatar model, it's going to be whatever you want as your people to show up. Right now it's a single one. Everybody has a shared avatar. Eventually we'll support more, but for now it'll just be one. Using fog. Fog is not a good idea in a small room like this because you can't see it. You don't have enough distance to see it, and in this particular case, if we clip through the wall, it's completely black, so you still wouldn't see it. There's nothing over there. But in a large setting, like if we go to the temple demo, in a large setting like this, perhaps fog might be a better idea. I don't have fog turned on here. Let's open that particular demo up. So here we see that use fog is not on. Use fog is false by default. And if we reload this, then we can see, we no longer see the background. You can see that it sort of fades out a little bit. So this is a way of hiding the edge of details. I didn't do a very good job of it yet. My fog setting is not far away. In general, I think that you're going to want to stick to much smaller environments anyway. The meeting room is a much smaller environment, and I think this is probably what's going to be best for designing WebVR applications to begin with. You're going to want to be able to support users on Google Cardboard or Gear VR or Oculus Rift in a seated position, or HTC Vive in a standing position, or even a seated position. And so you're going to be somewhat limited in the capability of your users to move around. You don't want to just as a good design habit, you probably don't want to make very wide, expansive environments, at least not yet, until we figure out better ways to move around within a scene that support more people. For now, if you're trying to be maximally inclusive for your users, then you want to have very simple scenes that don't require a lot of moving around. In this particular case, I don't have any collision detection on, specifically so that users can stand on top of chairs wherever they want, and then you can have multiple people standing around here, and it would look like we were having a meeting. VR icon is for when we have a headset plugged in. This is what will be displayed as the selection box. Over here, this is what I call a 3D icon. It's it's a model of a computer monitor, and it's giving us an option to something to go into full screen, standard two-dimensional full screen mode. There's another model that I have that is a Google Cardboard. If we had an HMD hooked up, then it would appear here. Actually, I do have an HMD hooked up, but I'm not running in the version of Google Chrome that supports it. Right now, you have to download a special build of Google Chrome. Google Chrome is currently in version. Let's see what it is. Google Chrome. Well, yeah, sure. Google Chrome is currently in version 51. It might be higher than that because we're getting an update right now. Google Chromium is version 52 here, and it has the WebVR bindings built into it. Now, this will not come out whenever 52 is released. It will not have it will not have WebVR available in it. They've given a timeline. 54 is the first version of Google Chrome that will have WebVR built into it. That's probably going to be sometime around October. We just had a message. I just heard a beep of some kind. No, I did not. I guess I do not have a message. I did mute my music. Okay. So I got Oculus Home going. And because Oculus Home is going, now we have visible that 3D icon of the Google Cardboard box. If the mouse and keyboard were working, then we could select this cardboard icon, and it would be as if we had clicked this button over here as well. What is this beeping? What is this beeping? There's some sort of beeping. It's not here. I don't have any sort of beeping like that. Is it here? It's not here. This is wonderful. Twitch is just great. So as a quick demo of multiplayer, let's go ahead and slam that one over there and that one here. Look up there. I'm going to reload that page as well as that page. Right, well, that makes no sense. I need them to be on the same page. And we will log in Sean PPY. Log in here, and then over here we'll have Sean2. While connecting to the server, an error occurred. Live radio, folks. WebSocket connection failed. WebSocket connection failed. Well, that's not good. That would be here. Aha, look at that. Our entire server has just fallen over. Address in use 443. Huh? Let's cancel that. Let's say npm run dev. And what happens? It was all a dream. Reload again. Open the browser over here. Let's try it now. That time it worked. I don't know. Don't know. Doesn't like me. We'll load it up here. Okay, you probably hear a bit of an echo from my headset because we have voice chat running in between the two. I'm going to flip over here. There is apparently a bug of some kind to where our heads are not rendering correctly. Weird. And that's not what we're focusing on today. I need to close this window because I can't think clearly to talk around it echoing in my head. That is weird. Close that. There we go. We're working on being able to click this thing and also the ground with the mouse. Woo! Are there viewers? Is that what's going on? Okay. Say, welcome to the chat room. Welcome to the chat room, Bowser. Why is this not going away? There we go. All right. Cool. Let's go to the side view here. Slide that open. All right, let's go ahead and try to get this working. So we don't need this because like nothing about picking objects is left up to the application. You respond to clicks. You can create an event listener. It would be on the environment here. You would add a click event listener, and then you would receive events telling you what happened when you clicked on something, what object you clicked on. But the actual process of figuring out what to click on is done in the framework. The rest of this code is all just login form related. 155 lines of code. If you have a much simpler way of doing a login form, then your VR meeting room demo would be a lot shorter than mine. So we can close that. We can close this HTML. So this is sort of where things start. This is the browser environment class again. It is a hairball of code. It is almost 1,300 lines of code. I'm working on shortening that down, but for a lot of these things, it makes some sense to have it all in one blob, because we have a very strong linear dependency between a lot of our code, and to maintain sort of an eye on how that code all relates to each other, it kind of makes sense to throw it all in one linear path, so you get a sense that the update function is really long, because it's visually very long. In this case, it's this move player, move sky, move ground. So this is really all just update code. Okay, let's go back to where we were. We fixed moving the player last session. So today we're going to fix moving the pointer. Well, we're moving the pointer. Today we're going to fix resolving the picking. Why does the picking not work right? We definitely get mouse and keyboard events correctly. Keyboard, mouse. There are other types of events, gamepad. So we probably don't need to be in here. We probably don't need to be in this class either. These pretty much work as expected. And there are Swift Rage heads. Interesting. I don't know what that means. Okay. It starts here. I'm passing in the projector to the move function, but I don't actually have the projector here. So what does that mean? I remember from last time that I had wanted to move the projector code, the actual call to fire the projector, into here. But since that time, I have decided I do not want to do that. I want pointers to be able to move themselves around, and that's about it. The environment will pack those pointers up, and there will be multiple pointers, and the environment will pack those pointers up and figure out what to do with them from there. Coffee. Okay. Okay. So we move the pointer, and then we resolve the picking, which is here. I'm going to move this function up closer, I guess 1, just so I can see it. So we never made the call back to the projector to say where the pointer was located. So I don't remember exactly how that's done. Maybe I can look in the actual projector code. Set object, that's probably not it. Update objects, nope. Set prop, no. Project pointer, this looks interesting. Okay. So this dot projector, if this dot projector dot ready. So the projector has potential to run really slow, and it's set up to run in a worker thread. It's a really bad out. I've used a pretty naive algorithm to where I loop over every object in the scene that has been marked as pickable, and then I loop over every face within that object, and I do some math to figure out if I hit it, if you hit that. And one of the one of the math bits that I do is inverting a matrix, which is not exactly a cheap operation. But okay, that's fine. You know, we're gonna go with it. I'll show you just how long it is. It's 3.matrix4.prototype get inverse to string. Boom. So that's the code it takes to invert a matrix. What's crazy is that this determinant calculation is not the same as back over here, this determinant. You can't invert a matrix if the determinant is 0. It actually doesn't make sense if it's even really, really small. You get what are called incontinuities, and so you want to be able to skip matrices that don't make sense. This is all about taking a point in two-dimensional space. Say this envelope here is two-dimensional space, and it's our screen. We move the mouse around on this screen, but behind this screen is the 3D world. So from camera to a point on the screen, through it to somewhere in the world is what we're trying to figure out. And in this particular case, and then in this particular case, say, well, actually, this is a useful abstraction here. Models have multiple shapes on them. They have triangles that they're made out of. So this whole envelope would be an object, one of these things. And then these individual parts would be a face. So I have this out in space somewhere, and I have my pointer. It's moving around, and I want to know if I fire this pointer from the camera, where you can see it out to the object, where does it strike it? Which one of these faces does it strike? And that's what all this math is about. Not only which face does it strike, but where within that face does it strike? Because that's the basis of our mouse movement, our mouse selections in the text editor. What would be a good idea is to have a configuration parameter to tell the framework, most objects, I don't care about subframe or what's called tangent space picking. I don't care about where within that triangle I pick. I just need to know that I picked that particular triangle. Or in most cases, actually, I don't care about the particular face. I just need to know that any part of the object was clicked. So that would save us some time on this, but we've not actually hit a fundamental limitation in our project yet that would justify complicating this code. So I'm just going to leave it. I'm going to leave it this way until we prove that we actually need something better. There's a principle called Yagni. You ain't going to need it. And it's a way that it's something I exploit to be able to move very quickly on projects. Okay. This dot projector dot project pointer. So pointer is going to be, we need to do this as an array, and Or does my wrapper do that for me? Workerize. Let me see. Workerize. Oops, that's the wrong version. Workerize. So Workerize builds a web worker thread out of a JavaScript class's source code and attempts to create a message interface that matches the message passing interface that the class already uses. So this is a way of taking a bit of code that you've already written. If it's designed in a simple way that follows what's called a message passing architecture for object-oriented programming, if you've written your class in that way, then you can box it up, workerize it, throw it off onto a separate thread. And in many cases, this will improve the performance of your application. And I have misspelled a number of different words. That bothers the hell out of me, so I'm going to fix it. Fix it while I'm here. So workerize, the question I have in my head right now is, did I write the workerize method, the workerize process, to automatically pack arguments up into an array? Because I know the other end expects an array, so method shim post messages to the worker thread by packing arguments into an array. But it expects args to be in an array. Or it expects it to be a single element. It doesn't actually need to be an array, but it expects it to be one parameter. And so to send more than one parameter, we have to pack them into an array. It does not look like it does the actual packing. Method shim gets called here, and it gets bound to individual names of methods. All right. All right. That answers that question. Projector expects two arguments: the point we are projecting through and the target from which, or the source from which we are projecting. And it expects them to be arrays. Oh, that's handy. So what I need is really just an array of two arrays. Where did I put that? Okay, and that array is going to be pointer.mesh.position.x .toArray. Boom. Oh no, you know what? There is a function. There's an issue here. Pickable object. Update pickable objects, create pickable object. Objects that are in the scene graph are positioned relative to their parent object. So if you just read the position of an object, it may not be where you think it is, because if it has a parent object, then it could be translated relative to that. I'm gonna have to clean up some of this stuff. There's way too many nude objects. New upped. There's more beeping. Nothing going on. So we take an object, we look for something inside of it that we can read, we can figure out what it looks like, almost never including the geometry. That is for registering pickable objects, it's not for using to fire pointers. And then I'm doing this whole process of walking the chain of parent objects to figure out what the final location of the object should be. I wonder, I bet that is not a good thing. I bet I'm not doing things right. 3.object 3D prototype dot apply Euler object get world position. No, local to world. Local to world. Vector. Apply matrix. Matrix world. No. Interesting. Is there anything that locks the chain? No, I guess not. Okay. Update bag matrix. Oh, this is right. Pointer dot mesh. Do we have that in here? Where is the pointer in relation to everything? It's on the scene. Okay, we don't have to do any of that translation. Not for the pointer, but we will for the camera. So that's fine. But this player position will not work once we move away from that position. So when project pointer gets called, we actually want to do this. This is a semaphore, it's called, and it makes sure that we don't call this function again until the callback fires, and that's done later. And this handle hit function. So here we set it back to true, and then we continue processing. This is important so that we don't overstack the projector with calls. They can stack up on top of each other and cause more latency. Just really degrade performance. So we just basically just skip times when it's busy. Okay, we're not going to worry about it directly yet though. We're just going to see what happens when we reload. And we've got the basics here. That's strange. Whoa, that's weird. That's weird. We got the basics of that particular object down. Okay, what about the ground? We don't have the ground? What about the gamepad? Okay. What about if we close that and go back to Chromium? And close that back down, and we're going to do the Oculus Rift mode. Oh, we are going to make ourselves puke if we're not careful. Okay, so I have done something terrible. I've made it possible for you to. I've got my headset here. I'm not moving my headset. And I'm moving my mouse. I can move it back and forth, moving the head around. This is going to make people throw up. I'm going to put it on my head right now. How awful is it? Oh, this is awful. This is disgusting. And the ground doesn't work. Alright. It's a different issue. We will come back to that. But what if I'm looking up, I look down. So that's what I thought. We're not getting the pointer updated right. Okay, so we reset the location of the pointer. We move it out ahead of us. It makes no sense. It does make sense, but okay. Let's see. I want to change how I render the pointer because it might make it a little bit easier to figure out what's going on. Is there a line geometry? Line. Line basic material. Okay. Is that actually what the object is called? Or what the class is called? Yep. Okay, what's line 3? Line 3. This is just a math object. We don't need that. Need line. Don't need line segments. let's go. Let's go to here. Let's go source base, and let's copy box to line. All right, and let's go line to JS. There it is. Line. Oh, it doesn't need to be. Okay, so these parameters will not be a variable length array of objects. Okay, don't need any of that. Okay, it's really just going to be a geometry, and we're not going to do an example yet. And line, and delete that, and okay. Our args equals array.prototype.slice.call arguments. And I'm going to need an ID. I'm going to need some way to. So args.map a vector, and that's going to be v.toArray join commas, and then join with pipes. And that will be the ID. And I'm going to reuse that for everything. ID. Okay. Is that how geometry works? No, that's not how geometry works. We just create a new one. Okay. This is the fastest way to loop over anything, so we might as well do it this way. What about geometry? Is that true? Okay. Geom.vertices.push. Turn geom. Okay. So if we ever call this, function with the same number, with the same exact arguments, vertices that match exactly to one we used before. This will actually cache it, and we will get it back again. We won't create a new one. So that's handy. Okay. Now that we have that, I'm going to have a line. Let's go and go from v3 0 0 0 to v3 0 0 -1 -10 -3. Alright, well, let's see. And then I'm not going to move the position of the thing. Line is not defined. That's because I need to now go back and run the generator. Could have sworn it was already running. Gulp, just hug. Yes, 6. And then come over to here. Alright. Looks like we probably got this. Expected token. Unexpected token. That's because... Where did I do that? Inline. Here. I don't know what that was about. Oh. So I'm going to go to empty demo because it's a little less resource intense. Oh, no, we just lost it. That's fine. Okay. Love the spinning flubber. Yeah. Okay, so something hates us right now. We have killed... We've killed something. Clar. Alright. Well, this is not going to be a line anyway. You know, this is a misnomer. It really is. Okay. Okay, so I'm renaming this function to geom, which is probably a mistake. Okay. And now we need textured. And now we need line equals not So that will convert to a Boolean there. Okay. And let's add, because then we don't want it to appear saying undefined. We want an actual true or false in there. Else if options dot line material type equals 3 dot line material. All right. That's what it's called, right? Line basic material. If options that line, we'll do it here, and then else, because then I'm going to do that there so that we can have more grouped options. Material type there. Material type. There we go. A little more organized. Okay. These don't make any sense here for the line, so they only make sense in these cases. Material options, because we're living in a material world. And I'm a material programmer. There we go. Okay. Now we set color. These are the ones we're going to okay. Material options. We're not going to set the color here. We're going to set it here though. That's not bandwidth. I know. Set the default value. Mm-hmm. Include that in the caching description. Set it for the material. And I'm gonna use that. Okay, let's see what happens. Okay, localhost the meeting. Oh well. I wanted to go to empty. What? We're gonna have to close the browser down. Good thing we're not relying on it to broadcast. Ah, doesn't like something that we've done. Oh, here we go. Let's try. Let's try making this. Let's just put it back to what it was briefly. Oops. I apparently clicked on Blender. Go away, Blender. Bad monkey. Point to radius 1010. We'll just put it back to where it was until we can see what we got out of the call for. No! What the hell? Let's see if that helps. We didn't change anything important there. We didn't change anything important there. Alright, fine. Let us... I can't believe this. I can't believe this is happening. This is such a pain in the ass. Okay. I don't really see anything. Why is that running? I don't really see anything that could possibly... Well... No wonder my computer is being so slow. Caps lock. Maybe we'll get lucky and we'll see the crash happen. Nope. Mm-hmm. Alright. Let's comment that out for a moment. Would be nice if that's what fixed it. It is. There's something else going on here. Strange indeed. Okay. I don't need args there. Oh, look at that. That's my fault right there. I made some sort of weird infinite loop. And it was just great. I love when I do shit like that. I'm getting errors out the wazoo. They're not showing up. Now we're up here. Okay, let's close that. I is equals 0. I is less than the number of arguments. Increment arguments. Okay, alright. Mm-hmm. Mm-hmm. Let's see. Let's undo the changes to that. And just get rid of that. Okay. Mm. Okay, where am I going? Oh, that's right. Chrome crashed, so it's not open right now. Yep. Can't read property set RGB of undefined. Okay, cool. It's because it needs to be there. And then we need to okay. There we go. If options dot line not align, we would not be setting any of these other values. But we will need to... What? Oh, I've done a terrible thing. No, maybe I haven't. I see. Oh, I see. There we go. I still got a sphere though. It's because I don't have the line. I'll do that. Gee, can we come back here? Did we ever? Oh, we did make that. Render count or prim count is 0. Uh-huh. Let's try that. No. Let's go back here. Line. Basic material. Line. Oh, it's because I need to make it a line. I have the material, but I didn't use... Okay. We're almost there. If options dot line new 3 dot line geometry material else. This is kind of a mistake. Okay, so whoa, look at that. That's crazy. That's craziness. I'm getting there though. I don't need that yet. I need one. Okay. It's spinning around like that. Move, because we moved it forward. That's not right. I want negative. Let's really put it out there. Yeah. Okay. Mm-hmm. I'm looking for where the player gets updated. Mm-hmm. Because maybe I just don't do it this way. Oh, I put it into the vehicle. Hmm. Yeah, makes sense. So the pointer needs to be based off of the vehicle, not the player. The vehicle is like a magic carpet on which the player stands, so that the player can move around with their headset independently of what they've indicated with their gamepad or their mouse. What does that do? Nothing. It does nothing. Let's move it forward just so we get a view on it. We got that view before. Why is it not? Why is it spinning? I mean, let's just stop doing that at all. Let's just not move it. Where is it? No idea. No idea. It's gotta be down there. Hmm. What if for the pointer we discard that and that? Yes. And what do we get? We get the ball. Okay. It's in the right position. It's probably spinning like a madman. Let's find out. Let's just squish it. It is. How can I represent that? I see. That real quick. Look at that. Zing! Really should not be spinning like that. So that means it's not set correctly. Hmm. So it's out there correctly. Reset to the identity quaternion. It seems to have done it. Is this right? Oh. Okay. Okay, so we got rid of that spinny problem. Let's try to make that line again. Make GOM, of course, is not a method. It's way out there. There we go. Well, let's do another thing. Let's back it up behind us a little bit. Okay. That's interesting. Doesn't look like it's coming from the... weird. So it's only coming from the difference between my last position and my future position. Ah, what? It's only... It makes zero sense. So it gets rendered and then I move... So it gets positioned and then I move and then it gets rendered. Okay. I guess that makes sense. Okay. Wonder how that's going to look in view. Let's find out. No, don't restore. Let's go for it. The hell? Somebody talking to me? Well, there's no way I'm gonna know. Okay. So I see the line. You can see me tilting back and forth, and you can see it. It does extend forward. I can't seem to get above or under it. I can get left or right of it. This is not right. That's kind of neat. But that's not what we want. Okay. Do we get a line width? Oops. I mean, there is a line width parameter, but I don't think it actually does anything on Windows. Oh my god. Oh my god, since when does that work? Holy shit. Oh, that's great. It moves with me, but that's alright. Okay. Alright. Okay. An idea for making that a little nicer, bouncing up and down. Bar player height equals null. If player height is null, player height is player.position.y. Alright, cool. And now we're going to subtract player height. Or no, we're going to add player height there, and we're going to subtract player height there. And then 0, this dot 0, we're going to set player height null again. Reload. Whoa. What? 0. No. Okay. Everything's got to be hard. Of course. Add velocity. Of course, I'm doing a constant. Right there. How about, okay. Okay, so that would be, at the first time that would be 0. Just set it. That's probably right. Oh yeah, okay. Yep, that seems like it was right. Okay, so we can get up and down and around. 0. Okay, cool. That's good. It's interesting how, because the line is actually a constant width across the screen, it looks like it gets bigger the further away it is. That's pretty neat. Optical illusion sort of thing. There is an artifact, though, of, because the orientation is different per eye, the end of the line doesn't match up correctly. So that means that line is actually kind of like stupid geometry. So we might as well just do like a really long box. Use that in a minute. Textured box. Chirp, 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 chirp. Choop, 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 choop. Some meter 0.01. I'm going to do centimeters. And I'm going to do 3 meters long. Okay, let's see what that does. Whoa, 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 whoa. Whoa, whoa. It's significantly better looking. Oh, you know what though? It's centered. What shall I do? And this dot mesh dot geometry dot vertices dot for each v dot z. Let's see if that does anything for me. Okay. I'm not gonna put it on. Oh yeah, that's actually kind of cool. So it's right there. It's all right. That's all right. Pointer is way out there, and yeah, I like this. So we don't really have the right sense of the pointer yet, but That's kind of cool. The laser beam is neat. Okay. Close that. Do we really need to copy it? What does this do? Okay. What does that look like? Probably looks insane. Oh, ow, ow, ow. Okay. Okay. It's fine. Let's do this though. Let's go. Laser length. Let's do that, and then what else? Oh, need to like bump it just a tad. So it's not like directly. That's still directly in the face. Why is that directly in the face? It's because I did the wrong thing. Still directly in the face. A little bit further. A little bit further. Let's make it a cylinder. Maybe some other time. It's really big. 1 centimeter by 1 centimeter. Why does it come right into our face? Because we're sitting forward. Oops. I didn't want to reload, but alright. Went to 0. Alright, that's not too bad. Okay. Alright. Let's see if we can make it pick something. So the interesting thing is really that, like, with the pointer like this, we can actually move around. And get the thing. Why? Why? Why does it lag? Anyway, pointer. So we've got it moving. Okay. we're going to do a printout of the position now, so that I can see if things are going the way I expect them to. Sort of. Yeah, this is not going to be nice. This is not going to be nice. What is... Hmm. Um, let's see what this looks like. Hmm. So this is right. Okay, this is... Alright. That's the whole point of that. Okay, so this is like directly out of our nose. We need to think of this one as directly out of our nose. Or... Yeah, that's what we'll think of that one as. So that later when we do the HTC Vive one, this should still work, move, because we'll be giving it the object that is the Vive controller, and it will copy that. So now, we've got two vectors. Origin. It's the null vector. Let me say origin.set. We don't need to do that. But forward. And then we do forward.apply matrix world. And now we log that out. Value to fixed, 5 digits. Console.los log. We need logs. Okay. Yeah. Interesting. That worked. Oh, that's good. Okay, so now let's do forward.sub this.mesh.position. Oh, excellent. So there we go. There's our direction vector. Pew 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 pew. So, okay. And all right. Cool. That gives now in the browser environment. P vector. Now this is actually a P ray. That's a ray. Yeah. If this dot projector dot ready, then this dot projector dot project. Oh, can we just send it P ray? And then projector project equals. It's not right. It's not the name of the project pointer. Okay. Stop logging that. Oh, okay, that's fine. It's not a function. That's correct. Pointer. 220. Oh, oops, I deleted. That was Sublime's fault. We're getting there. We're getting there. Okay, projector. PF. This dot P dot sub. Okay, this dot P sub C is this. Okay. Let's not overcomplicate this. Let's keep it at that. Let's go back to pointer and let's get rid of the subtraction. And then let's go back to browser and let's just call this segment. Now that it's 2 points, and reload, and what do we got here? What do we got? Nope. Nope, nope, nope. What's going on? Yep. So we're not actually hitting anything. Well, one thing, I need to do that. Oh, maybe it's because I'm too close. Does it look like? does a 1 meter long beam look like in the headset? It looks fine. Chopsticks. And looks like a yardstick. Oh, that's a great idea. Yeah, we're gonna interact with the world with yardsticks. Yeah, that's fine. Later, I'm gonna want this configurable. Okay. Okay. Because I need to fix that again. Now, why is this not working? It's because I have it backwards. I call it P. This is a bad name. Let's name these properly. Okay. So, let's go back to project pointer. Yeah. Nope, still not. Mm. Not even getting close. Do we have objects? Yes, we have 3. That is correct. We do have 3. Is the object not disabled? Objects are not disabled. Does it have faces? Yes, they have faces. That's strange. Oh, yes, they have lots of faces. Let's bump you down below. A little bit easier to read. Oh, wide. Okay. About. Do they support two-string? Nope. This was a mistake. If j equals 0, if I equals 0, and j equals 0, I'm gonna have to kill. Not a number. Look at that! So we found an issue. Come on, we're gonna have to kill Chrome. I'm gonna go back to regular Chrome. Just a touch more reliable. Not meeting empty. And that means we can also close Oculus Home. And, okay, and not a number. Wow. How did that happen? Okay. Ah. Ah. Not getting any parameters. looks like our music has stopped. Wow, I've been programming for 2 hours straight. Let's do it again. Alright, so pointer, move, turn. Oh, wow, look at that. I just did something weird. I just tried to make a tuple, which is not something JavaScript has. And now I'm creating an object in a tight loop. That's great. It's going to work out wonderfully for me. That's a little better. What is these undefined? These undefined. I think they're in browser environment. I'm only getting one. Okay. Why am I getting undefined back? Okay. Finally. Oh, look, there was green. Okay. 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 We're almost there. Some debugging hell. Okay, so now go back here and the pointer and register hit and not going to change the scale of anything. And we're not going to move. Not going to move it. We're not gonna scale a thing. Since we never set the scale in the first place, we don't need to reset it. Okay, let's try that. Aha! Registering a hit! Yes! And if we click it, alright! And there's the ground! And I think we did it. Certainly got the mouse. Keyboard is doing a similar thing. Alright. So in the second hour, managed to make it work. In a lucky shot, kind of. Okay, now check this in. So I actually don't like this anymore. I'm just going to delete it, and then I'm going to take all of these and discard them. It's just not a very good way of drawing lines in 3D space, especially with a stereo headset, so I'm just plain not going to use it. I like these changes. I'm going to keep them. Grouping code by purpose and indicating test code. Okay. And then that means I can get rid of the changes to textured. Okay. and I'm going to discard this. I don't really want it moved. Okay, and this is fix issue where player head movement where player vehicle does not tracks relative to horizontal head movement, but where player vehicle does not track vehicle tracks vertical head movement, which is not good. Okay. Oops. And that would be included in that last one. Yes. Okay. All right. And then this is... Oh, that's fine. Okay. Fix mouse and keyboard picking. All right, and we push. Okay. All right, everybody. Thanks for watching. Once again, this is Sean Macbeth here. I'm working on Primrose VR, web framework for doing virtual reality applications for Notion Theory. Notion Theory brings your product to market within 6 weeks, your minimal viable product for your startup within 6 weeks. So check us out if you got something that you want to build in virtual reality, but don't think you have the programming chops. Want to hire out to somebody to be your temporary CTO, give us a call.